All right, so we're beginning our next unit. It's the expressions and also a few other things that go with it, but you need to set up your workspace first. So if it's not already set up, pause the screen, get out these things, and be ready to go. All right, let's begin. Where this standard fits, here's kind of what we should know by the end of this lesson. Write and evaluate numerical expressions involving whole number exponents. So we're kind of just lay the foundation with exponents today and then move on from there. If I look at kind of where this goes, this is the progression of things. The order of operations is kind of the first big skill of this unit, but the foundation for that is just understanding exponents. So we're going to talk about that first, and then we'll come back to this with lesson 2. Then it kind of embeds itself in the rest of these. So we got to make sure we understand these skills first and foremost. If I look at where this goes, here are examples of where we see this. Okay, you see exponents and some problems. You might see order of operations problems with exponents outside parentheses here or there. You might see problems like this that involve exponents, and there's also one up here. So this is the kind of stuff that is expected at the 6th grade level. And let's keep it going. All right, if I start with the introduction here, first I want you to draw an array to represent a 5 by 5 grid. So go ahead and draw basically a square that is 5 by 5. You can see, let's see, stop popping up. You can see here an example of what that looks like, just 5 columns and 5 rows. So you should draw a 5 by 5 square. Over here it says, what does this picture represent? Okay, and you can see this in a few different ways. You can see this as a 4 by 4 square. You can see this as also 16 circles. Or we could even summarize this with an exponent. So we're starting with just this understanding that we're multiplying similar numbers, 5 and 5, 4 and 4, but that's kind of what exponents are. So let's dig right in. With exponents, you have a base. The base is the number being multiplied by itself. Okay, up here, we are multiplying 4 by itself. Over here, 5 by itself. So an example, 9 to the 2nd power, 9 would be the base. Okay, that's the number we would multiply by itself. 6 to the 4th power, well, 6 would be the base. The exponent, though, is the smaller number. It's the one that determines the number of times the base is multiplied by itself. So if we look at this example, 3 to the 5th power, we've already kind of decided 3 is the base. Well, that makes 5 the exponent. Okay, there's your first blank. In this one right here, 2 to the 7th power, 7 is the exponent. Any number raised to the 2nd power is said to be squared. Okay, we're going to come back to that later, but there are certain exponents that kind of have special names, and 2 is one of them. So that's just an introduction to what's the base and what's the exponent. If I look at these, you can fill these in pretty quickly because, again, the base is the bigger number. So like the 3 is the base. Over here, the 7 is the base. The 9 is the base. Go ahead and figure out what the other 2 are. You can see those, but the base is the bigger number. That means the exponent is the smaller number in the corner. So right there, the 4 is your exponent. The 3 is the exponent. In this one right here, 2 is the exponent. 9 would be the exponent for that one, and 0 would be the exponent for that one. So this is the exponent, this is the base. We actually call the whole thing the power. Okay, so this, when we talk about powers and bases and exponents, they all kind of are referring to this look right here. If we look at this table right here, you can see here, if you have a base of 5 and an exponent of 3, it would look like this. This would be your term, 5 to the 3rd power. So the term is just another word for power. Okay, so you can see here how we got that. Now, if I'm looking at 19 to the 2nd power, well, we already know my base would be 19 and the exponent would be 2. Right here, I don't know what the power is, but I'm given the information here. So what do you think that looks like? And you can check and see what you think. Here's what I want you to do real quick. Pause the screen and finish these over here as well, real quick. Okay, take a quick moment and check your work now. See if you did okay on those. Pause if you need to. Okay, so let's talk about different types of writing these. There's expanded form. This shows us the full multiplication of the base. For instance, 6 to the third power is written as 6 times 6 times 6. So that's expanded form. We've really taken this and expanded it out. Okay, right here, if we had 3 to the 6th power, well, that means we want to multiply 3 6 times. So in expanded form, that would look like that. Just a reminder that the dot is another way of showing multiplication. You can use the X or you can use the dot for multiplication. There's also standard form. Standard form is when a number is raised to a power or when the number is simplified. It is called standard form. You're going to see some examples shortly. So if we look at exponential form, well, this is what the expanded form is. So I know that an exponent form, that would be 5 multiplied 3 times, which is going to look like that. And if I were to actually solve that problem, 5 times 5 times 5, I would get 125. That's standard form. So we can see this in 3 different forms. These are all equivalent. They're all the same. So if I look at the next one, this is 36. Well, the question is, what number times itself can help me get there? Well, you might be thinking 6. I know 6 times 6 is 36, so that would be expanded form. And if I think about that as an exponent, that's going to look like 6 is my base, and I multiplied it 2 times. So I get 6 to the second power. So we have 3 different forms to kind of talk about these numbers, and they should be equivalent because they're representing the same quantity, really. Now, if I look at what we just did, here's what I want you to do for this part. I want you to pause the screen and see if you can figure out what's the expanded form of that and what's the standard form of that. You might need a calculator, you might not, but go ahead and pause it and give the rest of this table a go. Okay, you should be checking these now to see how you did. I really hope you're not just copying because that's not real good. So check your work, see how you did. Again, pause it if you need to because we're going to move on right now. All right, so one big thing, this is not in your notes, but we already kind of know that multiplication is really repeated addition. You've learned that in grade school. You know that if you add 3 over and over again, we could simplify that with multiplication up here. So we know that multiplication is really repeated addition. Well, now we're kind of bringing in the second concept here, and that is that exponents are really repeated multiplication. Because if you think about what's going on, you can see up here, if I have 3 to the second power, I am really multiplying repeatedly. And the exponent tells me how many times. The exponent here was 3, so I want that 3 3 times, and I want that 3 4 times, and 5 times. So we're kind of moving into this idea now that exponents are really just repeated multiplication. And a few other things that kind of come along with this, there are some most common exponents, okay? If you have a number with a 2 as the exponent or with a 3 as the exponent, we kind of talk about them differently sometimes. We might say that this is really squared, 5 squared and 12 squared. Now we could still say 5 to the second power and 12 to the second power, but squared kind of lets our minds know we're talking about an exponent of 2, even though we didn't necessarily say 2. So 5 squared, 12 squared, 100 squared, that's what 2's represent as your exponent. And you can think of that as a square as a 2-dimensional figure. Okay, you have a length and a width. But there's also another special term with powers, and that would be cubed. And you would say cubed sometimes when you're talking about an exponent of 3. Like I could say 5 cubed, okay, 8 cubed. And the way that that comes about is because a cube is a 3-dimensional figure. You have a length and a width and a height, or you can call that a depth, but you have a 3 as an exponent. So we have special names for just our exponents of 2 and 3. So if you ever hear squared and cubed, that's what those are talking about. Another thing that you can think about with this is how can calculators be used to help us with exponents? Okay, so I put some pictures here that you might see buttons sometimes that kind of look like this, where it might have a little exponent as part of the button. You might see this or this or that, or you might even see a caret or this or that, okay? So in a calculator, you might just type in 2 power of 26 if you're really trying to solve that. So the calculators are also able to, use exponents, and you just got to know what you're typing. If I look at the one that we have in the classroom, these buttons would be helpful with exponents. This would be the power button or the exponent button. And this would be a button you might want to use if you just want to square a number. Like if I wanted 7 squared, I could just do 7 and then that, and then hit the enter button. It'll know that's 7 times 7, and it'll tell me 49. On a phone, you might see different buttons like these, okay? These kind of apply to where we're at right now. 10 to a certain power. These are also like a square button or a cube button or just an exponent button if you want to use that. So these calculators are also designed to help you with exponents. Another thing to kind of point out is that there's this property in math called the commutative property. And it means that you can add or multiply things in any order, okay? Like we know these will give us the same answer because that doesn't really impact the outcome of the problem. One thing that you should know with exponents, though, is that they don't follow this property. They don't play by those rules. For instance, sometimes students think these are really the same thing, and that's not true. This first one is 2 5 times. The second one is 5 2 times. You can see here that we get different answers. So these two things are not the same, which means that exponents, they do not follow the commutative property. So keep that in mind as you're doing this. All right, if you keep going, I'm going to show you this one just to kind of bring up something into your mind that we're familiar with exponents, but eventually you'll also start seeing this. And this is not really going to be in 6th grade, but they do go forward and start talking about that along the way. So just kind of open up your brain to the fact that these things really do go further. Say what? Yeah, if that confuses you, don't worry about it right now. It's just extra information. If I were to summarize today's lesson, I would say there's a big thing to kind of just write down right here. You should write this down right now, okay? Exponents are a shorter way to write out bigger numbers. Pause if you need to, but that's kind of the summary for this. Okay, so your homework from this point on, what you should work on next is homework 1, and it's the very next page. But I want to do the first one with you together just so you have an idea of how that first section goes. If you look at this, draw a line from each exponent form to the corresponding expanded form and standard form. So like when I look right here for number 1, I see 3 to the 4th power times 7 to the 2nd power. And I've got to match that with one of these over here that really it is equivalent to. Now I can think about this. This is 3 4 times, and this is 7 2 times. So if I look there, that's this one right here. Okay, 3 to the 4th power, well, that's this. And 7 to the 2nd power, well, that's this. So I draw a line from here to here. And the standard form would be if I actually solve that. So you can use a calculator, or you can use your brain, or you can use the paper and pencil or whatever. But if I solve that problem, I think I get this one. And you can check that and make sure. But I now would draw a line up here. And so I would say that this is really that in expanded form, which is really that in standard form. Again, they're all equivalent and they represent the same quantity. They're just showing it in different ways. So you want to be familiar with this and this and this, and that's how that first section goes. At this point, shut your Chromebook and get to work on that rest of that worksheet. Have a great day.